Hello students, welcome to IMS Gate Academy. I hope you are doing great. Today Sunday evening, so it should be a fun day for everyone. But students who are preparing for GATE, it is the time to realize where you have to practice the conceptual problems. So students, in the previous sessions, I have been discussing the transportation on the topic geometric design. Mark my words and underline this video students. I am going to tell you the most interesting problems on traffic engineering where you can expect the problems. So let us quickly go into the topics. So my dear students, are you looking for the conceptual notes for the problems which are discussed in the YouTube? Then what are you waiting for? You have to join the Telegram group mentioned in the below link, and please click on the link and you will be directed to the Telegram group where you can access the classroom notes, or if you are willing for updates on our YouTube channel, definitely you will have that access and updates. Apart from this, you want to test yourself every day with some quizzes, definitely we will be posting some quizzes. And apart from that, my dear students, so let me go through what are the IMS features we are offering. My dear students, we proudly say that IMS is offering 800 plus hours of live GATE coaching, especially in civil engineering, the flow of subjects and also which subject has to be taken after which subject. Apart from this, we are providing subject test, mock test, multiple subject test, advanced test, and the most important one is the All India mock test. Remember, my dear students, when I talk about the All India mock test, you will have a definite access to the same as if like a GATE environment. How you prepare and write the GATE exam in the GATE environment, similarly you will be writing the the test as if in a GATE environment. Apart from that, we are providing the subject-wise material, chapter book, exercise book. In exercise book, we have level 1, level 2, level 3 questions where you can test yourself. And the most important thing, we are providing the 30 years previous question bank, GATE question bank, which carries key pointers and all. So these are all the features of the IMS GATE Academy. And remember, my dear students, we are offering the online GATE coaching as well as the offline GATE coaching. Online GATE coaching we are offering at Vijayawada, Ben Circle, and offline GATE coaching at Jayanagar, Bangalore. Apart from this, we are offering also the hybrid model, which includes both online and offline. And we are offering the online GATE coaching where you can access it from anywhere in the India. So this is all about the IMS GATE features. Now let us quickly go into the subject. So see students, before understanding, there is a question here. It's a beautiful question. A plot of speed and density of two roads is shown in the figure. Okay. So see students, here this is the question. If the capacity of road A and the capacity of road B is. Now let me tell you students, we have a model called green shield model. Now my dear students, we have a model called green shield model. This is a very important concept, my dear students. Okay, in green shield model, okay, when I talk about the green shield model, you should be aware of the graphs. So my dear students, if you see the green shield model, the graph between speed and density, if I draw the graph between speed and density, it varies linearly. So remember, my dear students, speed versus density graph varies linearly. Okay. Now see, my dear students, this is called, we call it as VF, and this is called KJ. Now my dear students, let me tell you, VF is known as free flow speed. VF is known as free flow speed. Okay. Similarly, Kj is known as jam density. What sir? Kj is known as jam density. Okay. Now, my dear students, when will be the flow will be maximum? Here, the traffic flow will be maximum. The traffic flow will be maximum if velocity is equal to Vf by 2, that is half of free flow speed. Okay. And also K is equal to, density is equal to Kj by 2. Okay, see students. Now the maximum traffic flow. If you remember, see students, traffic flow can be written as traffic density into velocity. How do you rate traffic flow? Traffic flow is nothing but density into velocity. So here, maximum traffic flow can be written as Vf into Kj upon 4. Okay. So this is the formula for maximum traffic flow. So for a flow to be maximum, the velocity should be equal to the half of the free flow speed, and for a flow to be maximum, density should be equal to Kj by 2. Remember students, what do you mean by traffic flow is how many number of vehicles are crossing in a particular time is nothing but traffic flow. So the units will be vehicle per hour. Traffic density means in a unit length of road, how many vehicles are crossing. That is called traffic density units are vehicle per kilometer. So here see students, capacity they have asked you. If traffic flow per lane, if they ask you traffic flow per lane is nothing but capacity. So see, if you consider road A here, if I consider here, 1 second students, if I consider the road A here, if I consider road A, here please understand UA represents free flow speed, and remember my dear students, KB represents jam density. Okay, and also see students, KB represents. Similarly, Ka represents also jam density for A, and Kb represents jam density for B. Agree? Similarly, UB will be equal to velocity of free flow velocity of B. Now see students, I told you clearly Qmax is equal to what, sir? Qmax can be written as Vf into Kj by 4, right? Now my dear students, if I write Qa here, Qa can be written as Ua into Ka by 4. Okay. Similarly, Qb will be equal to Ub upon Kb by 4. Capacity per lane, flow per lane is nothing but capacity. So if I talk about the capacity here students, so capacity Ca upon Cb can be written as Ua into Ka upon Ub upon Kb. So this is the traffic flow capacity, this is the traffic capacity ratios for the figure shown in the for road A and road B. So the option here is Ka into Ub upon Kb into Ub. So this was a GATE 2023 question. Just it's a very important question, see students. Okay. Now see students, this is another important point. Please read this question students. Just read this question students. The question here is, consider 4 points PQRS in the green shield fundamental speed flow diagram. Denote their corresponding traffic densities Kp, Kq, Kr and Ks. The correct order of the densities is. Now my dear students, these are densities. If you see, this is P, this is Q, and this is R, and this is S. So whenever these kind of questions are asked, here see students, if I consider this as graph between speed and density, if I consider this as a graph between speed and density, so this point is called Kj, and this point is known as Vf. What is this, sir? This point is known as Kj and this is known as Vf. Now, they have given in the diagram, this is the given diagram. They have given that the flow, if you see, 1 second students, okay, for the flow, okay, see diagram, the graph between flow, speed and flow, sorry, the graph between speed and flow. This is P, right? And this is given as Q, and this is R, and this is S. Now he is asking at these junctures P, Q, R and S, what will be the traffic densities he is asking. Now see students, at P, the value of Kj will be equal to Kp. This is traffic density of P. And at Q, this will be Kq. And if you see at R, this is Kr. And if you see at S, this is Ks. So, Kp is having, see, this length is obviously will be more than this length, and this length will be more than this length, and here it is 0. So, from the problem or from the figure, it is evident or clear that the traffic density of P is greater than the traffic density of Q, greater than traffic density of R, greater than traffic density of S. So, here the option will be, so if you are having the velocity minimum, traffic density will be maximum. If the velocity, like see, the velocity here, if the velocity is increasing, the traffic density is decreasing. Or you can write in this way, Q is equal to Kv, right? Q is equal to Kv. So here if you see, velocity is inversely proportional to Q by K. It is inversely proportional to the density. So from this, you can say this is the right answer. Traffic density of P is greater than traffic density of Q, greater than traffic density of R, greater than traffic density of S. So from this, my dear students, what will be the correct answer? Can anyone tell me? So here the option A is the absolutely right answer, which is Kp greater than Kq greater than Kr greater than Ks. Okay, is it clear, students? Okay. Now see, students, the next question, we have a beautiful question here is, a two-phase signalized intersection is designed with a cycle time of, good evening Rakesh, good evening. A two-phase signalized intersection is designed with a cycle time of 100 seconds. Okay. The amber and red time for each phase is 4 seconds and 50 seconds. If the total lost time for the phase to start up and clearance is 2 seconds, what is the effective green time? They are asking what is the effective green time. Now see students, let me tell you what is optimum cycle time. What is optimum cycle length, or what is meant by optimum cycle time is, it is the time taken for the one green to the next green is nothing but the cycle time. So here optimum cycle time can be written as green time plus amber time plus red time. Okay. Here optimum cycle time C0 is given in the problem as 100 seconds. Okay. And amber time is given as 4 seconds. And red time is given as, so 100 is equal to, green time we don't know. They have given amber and red time. They have given the amber and red time. Amber time is given as 4 seconds and red time is given as 50 seconds. Amber time is given as 4 seconds and red time is given as 50 seconds. So plus 4 plus 50. So what will be the green time? Green time will be equal to 100 minus 54, that is equal to 46 seconds. What is the green time, sir? Green time is nothing but the 46 seconds. But let me tell you what they have asked you, sir. They have asked you the effective green time. So remember, my dear students, when they ask you effective green time, it is denoted as GI. What is effective green time? Effective green time is denoted as GI. So here GI is equal to green time plus amber time minus lost time. Here see students, lost time can be two cases. Sir, see, lost time can be due to startup lost time, or it can be due to the all red time or all clearance time. So here if I talk green time is equal to how much we have calculated? 46. And amber time is 4 seconds minus lost time is 2 seconds. So the effective green time is equal to 48 seconds. So what are the key points in this problem, my dear students? The key pointers for this problem are simple. Optimum cycle time can be taken as green time plus amber time plus red time. Effective green time is nothing but green time plus amber time minus lost time. What is lost time? It is a summation of the startup lost time and all red time. If you can solve this problem with these things, definitely you will get an answer of 48 seconds. I hope this solution is clear for you. Thank you. Okay. Now see students, we have another important case, sir. What is the another important case? A traffic intersection has cars and buses randomly according to independent Poisson's ratio at an average rate of 4 vehicles and 2 vehicles per hour. The probability of observing at least 2 vehicles in 30 minutes is. Now see students, let me tell you. Sir, we have Poisson's distribution. We have the Poisson's distribution. So, if you talk about the probability of number of vehicles for a delay time of t, okay, P of n of t can be written as the formula e power minus lambda t, okay, into lambda t power n upon n factorial. Okay. Now, my dear students, what is lambda here? Lambda is nothing but vehicle arrival rate. What is lambda, students? Lambda is nothing but the vehicle arrival rate. Okay. Where t is the time and n is the number of vehicles. And remember, my dear students, remember, if the number of vehicles are not given in the problem, this is a very important point, key point. If the number of vehicles are not given in the problem, you have to assume that number of vehicles are 0. Agree? Now see students, here if you see the vehicle arrival rate of car is 4 vehicle per hour and 2 vehicle per hour. Okay. So here lambda of car is how much, sir? 4 vehicle per hour. And lambda of bus is 2 vehicle per hour. So what will be the lambda here? Lambda will be equal to how much, my dear students? Lambda will be equal to lambda of car plus lambda of bus. So this will be equal to 4 vehicle per hour plus 2 vehicle per hour. So this will be equal to 6 vehicle per hour. This will be equal to 6 vehicles per hour. And now, my dear students, here what is the time they have given? They have given time as 30 minutes. Agree? So time is nothing but 30 minutes means you can take it as, because here please understand students, usually how we do is, here the lambda units are vehicle per hour, right? If the lambda units are vehicle per hour, whatever the units here, we will try to convert the time units into that units. Suppose here it is hour, but here it is in minutes. So convert into hour. So 1 hour is equal to 60 minutes. So 30 divided by 60, which will be equal to 0.5 hour. This will be equal to how much, sir? 0.5 hour. Agree? Now, what he has asked in the problem is, at least 2 vehicles. The probability of observing at least 2 vehicles, 30 minutes is. Okay. Clear, students? The probability of, just write down these, students, lambda values and all. Okay, now see, students, here number of vehicles are not mentioned. Here number of vehicles are not mentioned. You can write it as a key point, students. If the number of vehicles are not mentioned in the problem, you have to take the n value as 0, which I have already informed you. So what they are asking in the problem, the probability of n greater than or equal to 2. The probability of n greater than or equal to 2. This can be written as 1 minus P of n is equal to 0, means n is equal to 0, 0 means you can write n of 0, means you can take n of 0, 0.5. This is what they are giving, right? Time, how much they are giving, sir? Time they are giving probability of n greater than or equal to 2. Am I clear or not, students? Am I clear or not, sir? N is equal to 0, 0.5 minus probability of n is equal to 1, 0.5. Sir, P of n of greater than 2 can be written as what, sir? 1 minus P of n 0, 5 minus. So here what you can write is 1 minus e power minus lambda t power n, e power minus lambda t into lambda t power n upon n factorial minus e power minus lambda t into lambda t power n upon n factorial. Okay, here what is this value? 1 minus lambda t, we got it as 6, t is 0.5. N is equal to how much, sir? Lambda t power 0 upon 0 factorial. Here minus of e power minus 6 into 0.5 into 6 into 0.5 into 3. N is 6 into 0.5 power n into 1 factorial. Agree, students? Here I have just substituted the n values and all. So this will be equal to 1 minus e power minus 3. You can write it as 3 into e power minus 3. So what will be this value? 1 minus 4 into e power minus 3. What will be this answer, students? Can anyone tell me? What will be this answer, sir? So this will be equal to 0.8. This will be equal to how much, sir? 0.8. So remember, see, students, what are the key points here is the probability of n comma t, where n represents the number of vehicles, t represents the time, is given by the formula e power minus lambda t into lambda t power n upon n factorial. Here what I would like to tell you is the probability concept. If they give you, here they have given P of at least 2 means P of n greater than or equal to 2. This can be written as 1 of P of n of 0, comma P of n of 1. Time will be constant everywhere, right? So by applying these two formulas, you can solve the problem, okay? Now please solve this problem, students. Okay, students. Now see, students, what he has asked in the problem here is the vehicle count obtained in every 10-minute interval is given in the table 0 to 10, 10 to 20 and all. What is the peak hour factor for 10-minute sub-interval? So he is asking what is the peak hour factor. So peak hour factor, can I write it as total hourly volume, okay sir, what is the total hourly volume divided by, they have asked you for which time interval, sir? 10-minute time interval, right? They have asked you for 10-minute time interval. And remember, see students, they have asked you for 10-minute time interval. And what is the peak value we have? Peak value is 15. So for 1 hour, how many 10 minutes are there? 6 into 10 minutes can be written as this. So here what I will write is total hourly volume into 6 into maximum vehicle count for 10 minutes. What, sir? Here peak hour factor is what, sir? Peak hour factor is total hourly volume upon 6 into maximum vehicle count for 10 minutes. Now let us add the total hourly volume. Total hourly volume is what, sir? The summation of these values. So you can write here total hourly volume is equal to total hourly volume. Total hourly volume is equal to what, sir? This is equal to 10 plus 11 plus 12 plus 15 plus 13 plus 11. Okay. Here total hourly volume is how much, sir? 10 plus 11 plus 12 plus 15 plus 13 plus 11. So 10, 21, 33, 48, we have 13. It is how much, sir? 61, 72. So total hourly volume is how much? 72. Total hourly volume is 72. So if you talk here, the peak hourly factor, what is the peak hourly factor we have? This is the total, this is the total hourly volume divided by, as see why I am multiplying with 6 students. As it is a 10-minute interval, I am taking 6. If it is a 15-minute interval, we will take 4. 4 into maximum vehicle count. Maximum vehicle count in 10 minutes. So here see students, peak hour factor, if I talk about the peak hour factor, the total hourly volume is how much, sir? The total hourly volume is how much? It is 72 divided by 6 into maximum vehicle count. What is the maximum vehicle count, sir? This is 15. So this value will be equal to 72 divided by 90. So this is equal to 0.80. So this is equal to how much, sir? This is equal to 0.80. Okay. So the peak hour factor in the problem we have is the answer is 0.82. Clear, students? Because 70 divided by 9, 90 is 0.8. Now see students, just go through this question. This is a wonderful question, sir. I'll give you 1 minute of time. Just go through this question. Okay, see students, let me tell you this question. Okay, here let me read the question. The question here is, for a traffic stream, V is the space mean speed, K is the traffic density, Vf is the free flow speed, Kj is the jam density. Assume the speed decreases linearly with relation. Which of the following statements are correct? Now let me tell you one important thing, students. If you see the graph between speed versus density, if you see the graph between speed versus density, as I told you in the problem also they have given, speed versus density is given as V is equal to velocity and density. What, sir? Velocity and density varies linearly. This was given in the problem. And remember, see students, this indicates jam density, which is Kj. Okay, Kj is known as jam density. Okay, Kj is nothing but jam density. And here we have, which is called Vf, which is known as free flow speed. Vf is nothing but what, sir? Free flow speed. Okay. Now, what I would like to tell you here is, Kj is called what? Jam density. Vf is known as free flow speed. Now, let me tell you one important thing, sir. The straight line equation y is equal to what, sir? The straight line equation y is equal to what? Mx plus c. The straight line equation y is equal to what, sir? Mx plus c. What is y here? Y is nothing but v and x is nothing but density. So you can write v is equal to mk plus c. Okay. Sir, this is the basic mathematics approach for a straight line equation. Now see students, at k is equal to kj, at k is equal to kj, at k is equal to kj, what is the velocity here? Velocity is nothing but 0. At k is equal to kj, velocity is 0. Now, at k is equal to kj, at k is equal to 0, at k is equal to 0, v is equal to vf. Okay. Now see students, let me apply this equation. Let me apply this equation. Here v is equal to what, sir? Vf. I am applying this equation, sir. K is equal to 0, v is equal to vf. So vf is equal to m into 0 plus c. So what will be the value of c? C value will be equal to vf. What will be the value of c? C will be equal to vf. Similarly, C students, at k is equal to kj, v is equal to 0, mkj plus c. So m can be written as minus c upon kj. But what is the value of c? It is nothing but vf. So m can be written as minus vf upon kj. Okay, is this clear students? Very good. Now you know the value of m and you know the value of k. Okay, now we know v is equal to mk plus c. Okay, c is equal to what, sir? vf, and m is equal to minus vf upon kj. Now you got the values of c and you got the values of m. Once you got the values of c and m, just plug in these values in velocity. So v is equal to vf into m is what, sir? Minus vf upon kj into k plus vf. Okay. So my dear students, if I take here v is equal to vf common, this can be written as 1 minus k upon kj. So here you know v is equal to vf into 1 minus k upon kj. Now what is the formula for traffic flow we have? Traffic flow Q can be written as traffic density into velocity. Okay. Here Q can be written as traffic density is K into V is equal to, you can apply this formula, Vf into 1 minus K upon Kj. Okay. Here you can write it as Vf into K minus Vf into K square upon Kj. K square upon Kj. So this is the equation which we have developed for the traffic flow. So let us see the options here. So we have Q is equal to what, sir? Vf into K. Q is equal to Vf into K minus Vf into K square by Kj. So option C is B is correct. Option D is wrong because it is no Vf is there. So this is wrong. Now we have to check the third option and fourth option also. Is there anything other relation? Now let me tell you, see students, he has told that velocity and density varies linearly. So on the x-axis I have taken density and on y-axis I have taken velocity. Now let me take density on y-axis and velocity on x-axis. What do you mean by K? Traffic density. What do you mean by traffic density, sir? It is the number of vehicles. It is the number of vehicles. Okay, K is nothing but the number of vehicles which are crossing a particular length. Okay, or the number of vehicles which are occupied in a unit length. So the traffic density is nothing but vehicle per kilometer units. Velocity which you know already. So here if you see the graph, this value will be equal to Kj. This is the traffic density. And here we have is the free flow speed. Okay. Now the same thing against C students. We have y is equal to what, sir? Y is equal to mx plus c for straight line equation. Here y is what, sir? K. X is what? Velocity. So it can be written as mv plus c. So k can be written as mv plus c. Now see students, at k is equal to kj, at k is equal to jam density, v will be 0. And at k is equal to 0, v will be equal to vf. Okay. Now see students, if I apply the equation 1 at k is equal to kj, what is v? So k will be equal to kj is equal to m into 0 plus c. So c will be equal to kj here. What will be c, sir? C will be equal to kj. Are you following, students? Okay, very good. So here you got c is equal to what, sir? Kj. Similarly, at k is equal to 0, v is equal to vf. M into vf plus c is what, sir? Plus c. So you can write m is equal to minus c upon vf. M is equal to what, sir? Minus c upon vf. Now what do you mean by c, sir, here? So m can be written as minus kj upon vf. What is m here? M can be written as minus kj upon vf. Okay. Now see students, we know the value of c, we know the value of m. Now we have to just plug in these values. K is equal to minus kj by vf into v plus what is c? C will be equal to kj. So if you see here, students, from this equation you can write k is equal to kj into 1 minus v upon vf. What, sir? 1 minus v upon vf. This is an important relation. Okay, now you can write q is equal to what, sir? K into v. So k is nothing but kj into 1 minus v by vf into v. So you can write it as kj into v minus kj into v square upon vf. That's what k is equal to kj into 1 minus v by vf. Yes or no, sir? Now see students, here we have the option D. This will be wrong, and option D. So we have done the two relations, sir. So what are, see, option D is correct. So it's a multiple select question, students. The answer here is option B and D. Option B and D are correct. Okay. Option B and D are correct. Okay. Now see students, we have another thing. Assume that traffic on a highway obeys the green sheet model. The speed of the shock wave between between the two traffic streams P and Q are shown in the diagram. They have given the values, and here I'll give you 1 minute of time. Just try to solve the problem. sorry, here again I am telling you, the slope of flow density, the slope of flow density curve will give you the velocity of shock wave, will give you the velocity of shock wave. Here y-axis represents, here y-axis represents the flow and x-axis represents the density. So here they have given dq upon dk. So they might have given you two things. One is flow speed of P and other one is flow speed of Q. Okay. Flow of P is 1200 vehicle per hour and the flow of Q is nothing but 1800 vehicle per hour. Okay. And they have given velocity of P is 60 kilometer per hour and velocity of Q is, how much sir they have given? They have given us 30 kilometer per hour. Okay. Now see students, what will be the dq? It is nothing but you can write it as flow of flow of Q minus flow of P upon, how do you get density here? So you know the velocities, so you can directly take Q upon V because you know Q is equal to KV. So V can be, so K can be written as Q upon V. So you can write here, okay. What you can write, sir? Velocity of P. Q is how much? dq means you can write here velocity of Q. Okay. This is flow, sir. Now density can be written as what, sir? Flow of Q upon velocity of Q. Similarly, flow of P minus velocity of P. Okay. See students, here when I talk about the flows, the flow difference is how much? 1800 minus 1200. Okay. Now what we have? Q, the flow is 1800 divided by 30 minus 1200 divided by 60. So 1800 minus 1200 is 600 and this is 60 and this is 20. So you will get 40. 60 by 40 is nothing but 15 kilometer per hour. So what is the velocity of the shock wave? The velocity of the shock wave is nothing but 15 kilometer per hour. So let us see. Okay, it is anyhow, you can write the answer here as 15 kilometer per hour. Now my dear students, let me tell you one important thing. What is the key point in this is, the velocity of the shock wave is nothing but the slope of the flow and density curve. That is the reason it is given as dq upon dk, but traffic densities are not given. Again you should know traffic density is equal to flow into velocity, density into velocity. By applying these formulas, if you just plug in those values, you will get the answer as 15 kilometer per hour. Okay. Now just solve this question, students. given you enough time, Amma. I've given you enough time. The question here is the lane configuration with the lane volumes in vehicle per hour for a 4-arm signalized intersection is shown in the figure. There are only two faces. One is from the, you can say this is north and this is south, and this is east and this is west. So what he is asking is calculate the optimum cycle length. Okay. Sir, that where the delay is minimum, that is the optimum cycle length. So here see students, here what I would like to tell you is optimum cycle length is given by the formula 1.5 into L plus 5 upon 1 minus Y. Okay. See students, what is L here is, L is nothing but the total lost time. What is L, sir? L is nothing but the total lost time. And Y is nothing but, here we have only two things, either from north to south direction or east-west direction or anything. Okay, we have two things. So it will be taken as Y1 plus Y2, where Y1 indicates Q1 by S1 and Y2 indicates Q2 by S2. Okay, Q1 by S1 and Q2 by S2. Now, my dear students, let me tell you what is Q1. Q1 is nothing but the normal flow, and S1 is known as the saturation flow. What is Q1? Normal flow, and S1 is known as the saturation flow. Okay. Now see students, let me tell you here. Here what I would like to tell you is what is the total lost time. See students, here if you see in these two cases, if you consider north-south, which is the maximum value, here it is 396. So Q1 is taken as 396. And similarly, out of these, in east-west corridor, if you see, what is the maximum value? Q2 will be equal to 504. But what is the saturation flow rate? Sir, see, the total lost time, if you see here, the total lost time is given as 9 seconds. Okay. And they have given you another important case. What is the total saturation flow, sir? What will be the total saturation flow? Can anyone tell me what will be the total saturation flow? Okay. See students, what will be the total saturation flow? Anyone students here? See, intersection is shown in the figure. There are only two phases. The first phase is from west to east and the second phase is from south to north with a saturation flow of 1800 vehicles per hour. So here saturation flow S1 or S2 will be equal to 1800 vehicle per hour. And this is also 1800 vehicle per hour. Okay, these are the questions, these are the given data. Now, my dear students, let me tell you what is optimum cycle time. It is given by the formula 1.5 L into plus 5 upon 1 minus Y, where L indicates the total lost time. Y is the summation of the ratios of the critical lane ratios. What is critical lane ratio means? It is the ratio of normal flow to the saturation flow. So here what is the optimum cycle time here we have is the total lost time is given as 9. So 1.5 into 9 plus 5 upon 1 minus Y. 1 minus Y can be written as what, sir? Y1 plus Y2, which is equal to 396 upon 1800 plus 504 upon 1800. Now, my dear students, what is 396 plus 504? 396 plus 504 is nothing but 900. 900 divided by 1800 is what, sir? 0.5. So if you do here, the numerator will be equal to 18.5 minus 1 minus 0.5. So 1 minus 0.5 is nothing but 0.5, which is equal to the 37 seconds. So the optimum cycle time, The optimum cycle time is nothing but 37 seconds. So my dear students, what is the key pointer from this problem is the optimum cycle time is given by the formula 1.5 L plus 5 upon 1 minus Y, where L indicates the total lost time and Y is the summation of the critical lane flow ratios. Here critical lane flow ratio is nothing but the ratio of normal flow to the saturation flow. So I hope this solution is clear for you. So let us move on to the next problem. So please solve this problem also, see students. I'll give you 1 minute of time. Please see here, the question here is the vehicle arrival rate at an isolated intersection follows the Poisson's distribution. The mean vehicle arrival rate is 2 vehicles per hour per minute. The probability that at least 2 vehicles will arrive in 1 minute. Okay. So see students, here as I told you, the probability of n of t, where n indicates the number of vehicles and t is the time. The Poisson's distribution is given by the formula e power minus lambda t into lambda t power n upon n factorial. Here my dear students, let me tell you, the lambda value is given as 2 vehicles per minute. And the time is given as 1 minute, sir. Time is given as 1 minute in the question. So t is equal to 1 minute. And remember my dear students, when number of vehicles are not mentioned, you have to take the n value as 0. Okay. This you can remember as a key point also. Now see students, he is asking what is the probability of n greater than or equal to 2. So when they ask you n greater than or equal to 2, 1 minus of p of n comma 0 time 1 minute minus of p of n comma is equal to 1 comma 1 minute. Okay. Now see students, if I apply this formula 1 minus e power minus lambda into 2 into lambda t power 0 is nothing but 1 upon 0 factorial minus of e power minus 2 into lambda 2 into 1 power 1 upon 1 factorial. So my dear students, on substitution these values, you will get 1 minus e power minus 2 minus of 2 into e power minus 2. So this will be equal to 1 minus 3 into e power minus 2. Okay. So when I write here 1 minus of 3 into e power minus 2, you will get a value of 0.5939. So students, whenever probability, see students, there is a formula for negative exponential also. There is another formula called negative exponential, where you will take the f of t value as lambda into e power minus lambda t. Okay, lambda into e power minus lambda t. There this. Okay. This formula is applicable in case of negative exponential. This formula is for Poisson's distribution. This is a classical problem, students. We have seen n number of times these kind of questions. So please solve this question. I'll be happy if you solve this question. Now see students, they have given one beautiful question here. On a road, the speed density relationship are given by the formula U minus 70 minus 0.7 k. At the capacity constant, the average time headway will be. What they have asked you students? What will be the average time headway? Now see students, let me tell you what is the average headway. First of all, U is given as what, sir? What is the value of U given in the problem? It is given as U is equal to 70 minus 0.7 k, where U indicates the velocity, students. Okay, here I can write this as U is equal to 70 into 1 minus 0.7 upon 70 into k. Now this again I will write it as 70 into 1 minus k upon 70 divided by 0.7. Okay, this is V. Okay, this is U, that is velocity. Okay, now see students, we know velocity V is equal to what, sir? V is equal to Vf into 1 minus k upon kj. Okay, this is the actual equation which you have derived in the previous problems also. From this linearity, Vf can be taken as 70 and kj can be taken as 70 upon 0.7, which is equal to 100. Okay. Now see students, here you know the value of 100, that is traffic density and velocity. Now what is the maximum traffic flow we have? Maximum traffic flow is equal to Vf into kj by 4. So Vf into kj by 4 is nothing but 70 into 100 divided by 4, which is equal to 1750 vehicle per hour. That is equal to, what is the maximum traffic volume, sir? The maximum traffic volume is nothing but 1750 traffic vehicles per hour. Okay. Now here, let me tell you. You can write Qmax is equal to, or maximum traffic flow is nothing but capacity. Capacity can be written as is equal to 3600 divided by ht, where ht indicates the time headway. Where ht indicates what, sir? Time headway. So 3600 divided by 1750. Okay. So it will be roughly 2.05 seconds. So the time headway t will be equal to how much, sir? The time headway t will be equal to 2.05 seconds. So here if you see the answer, or you can write 2.1 seconds. If you do, you will get 2.055, or you can write the answer as 2.1 seconds. Is this clear, students? So what is the key takeaway from this problem? The key takeaway from this problem is the capacity, if you find out, means you have to find out the maximum traffic flow, where you will consider the velocity and the jam density. And remember, my dear students, the flow will be maximum at half of the jam density and flow will be maximum at half of the free flow speed. We have converted the equation into generalized equation. We have dragged the Vf and Kj and we have plugged in the values in the maximum traffic flow. After calculating the maximum traffic flow, we have equated per hour, there are 3600 seconds. So time headway means the vehicle distance between two vehicles to cross a particular road. Okay, here time headway is nothing but 3600 by ht. Here where the maximum velocity flow is nothing but 1750. On substituting this, you will get 2.05 seconds. Now please solve this question, students. Now see students, what is the question they have given is, the spot speed of vehicles are observed at a point on a highway are 40 km per hour, 55 km per hour, 60, 65 and 80. Okay. Now see student, what he is asking is, the space mean speed of the observed vehicles is. Remember my dear students, here if you talk about the space mean speed, it is nothing but the harmonic mean speed. So space mean speed is given by, where n is the number of spot speed, I is equal to 1 to n, 1 upon Vi. Okay. This is the formula for space mean speed. In this, they have given velocity V1 is equal to how much, sir? 40. V2 is equal to 50. V3 is equal to 60. V4 is equal to 65. And V5 they have given 80, I think. V5 is nothing but 80. V5 is nothing but how much, sir? 80 km per. 40, 50, 60, 65 and 80 km per hour is the velocities they have given. Okay. V2 is how much, sir? V2 is given as 55 km per hour. All the units are in kilometer per hour. Now see students, if I talk about the space mean speed, how many numbers are there? Here there are 5 spot speeds. Upon, you can write 1 by 40 plus 1 by 55 plus 1 by 60 plus 1 by 65 divided by 1 by 80. Okay. Yes or no, students? Am I clear or not? So 1 by 40, you can write 0.025. If you solve these things, students, you will get space mean speed is equal to 56.99 km per hour. Space mean speed. If they ask you time mean speed will be equal to average. If they ask you time mean speed, students, it will be equal to sum of the initial means velocities V is equal to I to 1 to n upon n. Okay. But if this is what, sir? This is the time mean speed. And this formula, whatever we have, here whatever this formula we have is the space. This is nothing but the space mean speed. This is nothing but space mean speed. Okay. Clear, sir? Let us go into the next problem. So if you take the key points in this problem, students, the key points will be the space mean speed will be the harmonic mean speed and time mean speed will be the average mean speed. Okay. Now please solve this problem, students. Now see, Here what they have asked you? They have asked you, they have given annual average daily traffic round off to the positive integer. And they have given the monthly adjustment, daily adjustment factor and the monthly adjustment factor. Now see students, the monthly adjustment factor can be written as annual average daily traffic upon average daily traffic. What, sir? Monthly adjustment factor can be written as annual average daily traffic divided by average daily traffic. Now see students, here what is the monthly adjustment factor given in the problem? They have given the value as 0.193. So see, the monthly adjustment factor is given as 0.913. Our daily adjustment factor is given as 1000, right? Sorry, daily adjustment factor is given as 1.121. So annual average daily traffic is asking, right? And he is asking the 24-hour traffic count was found to be how much, sir? 1000, right? So here 0.0913 is equal to annual average daily traffic upon average daily traffic is taken as 1000 multiplied by the factor which is given as 1.121. So what will be the average annual daily traffic here? What will be the average annual daily traffic? It is 1000 into 1.121 into 0.913. So if you solve this, you will get a value of 1023.47 vehicle per day. So remember, say students, what is the key point in this problem here is the monthly adjustment factor can be defined as annual average daily traffic upon average daily traffic. Here monthly adjustment factor is given, daily adjustment factor is given. So the traffic count is given as 1000. On solving this, you will get 1023.47 vehicles per day. Now another important question, please solve these questions. Okay. Start the timer. Now see students, they have given a question, the maximum number of vehicles observed in any 5-minute period during the peak hour is 160. If the total flow is 1000 vehicles, what is the 5-minute peak hour factor? Okay. Now let me tell you here. See students, here peak hour factor, just now I told you, peak hour factor is given by the formula peak hour factor is equal to, okay, total traffic flow upon, sir, I told you what is the maximum vehicle count, okay, maximum vehicle count. Here they have given 5 minutes. 5 minutes means if you take 1 hour, 60 divided by 5, which will be equal to 12. So here the traffic flow is how much they given, total traffic flow or total hourly flow. Total traffic flow in a hourly is 1000 and maximum count vehicle count in 5 minutes is 160 into 12. So this will be equal to 1000 divided by 1920. So which will be equal to 0.52. So what is this value, sir? 1920, which is equal to 0.52. Remember, what is the peak hour factor means? It is the maximum traffic flow you have to consider in a hour upon what is the maximum vehicle count in 5 minutes multiplied. Sir, if it is 5 minutes, you will take 12 times. If it is 10 minutes, you will take 6 times. So depending upon the vehicle count for interval, for time interval, these 12, all these values will be changing. I hope this solution is clear for you. Now please solve this question, students. See, please go through that question, student. Students, I have given you enough time. We have done this kind of problem also. The speed density relationship is 100 minus 0.5 k, where u is the speed in kilometer per hour and k is the density. Now see, students, what is u? U is equal to 100 minus 0.5 k. Now, my dear students, whenever they have given a relation between speed and density, whenever they give you the relation between speed versus density, okay, we have the relation V is equal to Vf into 1 minus k upon kj. V is equal to Vf into 1 minus 1 upon kj. Okay. Now see, students, here if you write this equation in this form, what I have to write? U is equal to 100 minus 1 minus 0.5 by 100 into k. Still, we can write it as 100 into 1 minus, okay, students, 1 minus 100 divided by 0.5 upon k. From this, if you compare these two equations, here you can write Vf is equal to 100, Kj is equal to 100 upon 0.5, which is equal to 200. Sir, what is traffic velocity will be kilometer per hour and flow will be, traffic density will be vehicle per kilometer. So if you know the relation, Q is equal to what, sir? Traffic density into velocity. So traffic density is 200 into 100. It is 2000. 200 into 100 is how much, sir? Sorry, 20,000. But if they ask you maximum flow, you can write it as Vf into Kj upon 4. Okay, Vf into Kj upon 4. What is Vf for us, sir? Free flow speed. So here Qmax is equal to 100 into 200 divided by 4. That is equal to 5,000 vehicle per hour. 5,000 vehicles per. So this answer will be equal to how much, students? You can write as 5,000 vehicle per hour. Okay, because they have asked you the maximum traffic flow. Okay, is this clear, students? Now this is a very interesting question. Please solve this question. I'll give you 2 minutes of time and I want everyone to try this problem. Very interesting question, students. Now see, students, here the average delay per vehicle, the average delay per vehicle is given by the formula C naught by 2 into 1 minus Gi by C naught whole square upon 1 minus lambda upon mu. Okay. See, students, what is you mean by effective green ratio? What do you mean by effective green ratio? Effective green ratio is given by the formula Ga upon C naught. What is effective green ratio? This is nothing but effective green ratio. See, students, here lambda is known as arrival rate and mu is known as departure rate. What is lambda, sir? Lambda is known as arrival rate. Mu is known as departure rate. Okay. Now, this is the formula for what, sir? Average delay per vehicle. Okay. Now, see, student. Here, actually, they have given some things. They are asking the saturation flow, normal flow and all. The diagram is like this, see, students. If you see the diagram, if you see the diagram here, the diagram is given as Q length, it is given as 9, this is 10, and this value is 60. Here it has 90 and it has 96. Sorry. Now see students, if you see the diagram here, if I take number of vehicles on y-axis or cumulative number of vehicles on y-axis, and if I take time t, see students, this is very important if you can understand the diagram. This line indicates arrival rate. Okay, this indicates what, sir? Arrival rate. And this line, whatever we have this indicates departure rate. This indicates what, sir? Departure rate. Now let me tell you one thing. Here we have this, okay? We have this value somewhere 60, which is given in the problem. Now see, this value is 10. For n is equal to somewhere here, n is equal to 10. For 60 seconds, number of vehicles are 10. For 96 seconds, sorry, first we will do it for 90 and 96. Okay, they have given 90 and 96, right? For 90 seconds, what will be the number of vehicles means what, sir? 90 into 10, 90 into 10 divided by 60. So this will be 60, 90 by 60, 1.5. That will be equal to 15 vehicles. So this is nothing but what, sir? 15 vehicles. Similarly, for 96 seconds, it will be equal to 16 vehicles. Okay. So see students, if I draw here 90 value, this will be equal to how much? This will be equal to how much? 15. Similarly, if you draw here 96, the time here we have is 96 seconds and the number of vehicles are 60. Okay. Now, what is asking in the diagram? Average delay per vehicle. Or if they ask you, first of all, let me tell you one important thing. If they ask you saturation flow or if they ask you arrival flow, arrival rate, that is nothing but slope of arrival flow. So what is slope of arrival flow means? This line. Okay, if we consider this line. Okay, sir. Am I correct or wrong? So if I consider this slope of this line means here it is 96. Okay, if I can take anything, 1650. 96 minus 6. Okay, y2 minus y1 by x2 minus x1. So 16 minus 15 divided by 96 minus 90. So this will be equal to 1 by 6. Okay. Here what is 1 by 6? Number of vehicles. And here it is seconds. If they talk, this is 1 by 6 of a second. But here you have to talk in hours. So 1 by 6 into 3600. So this will be equal to 600 vehicles per hour. This will be equal to how much, sir? 600 vehicles per hour. Now, this is called what, sir? Departure. This is called departure rate. And here you will get slope of departure rate. Here if you see, now next page. Now see students, as I am drawing again, here we have this is arrival rate and this is departure rate. This is departure. This slope will give you the saturation flow. So here it is how much, sir? 60 and here we have is 96, 90, sorry. This is 15 and here we have is 16. Okay. And we have here is 96. Okay. Now this slope line means we have 90 minus 60. Okay, x-axis, y-axis is 15 minus 10. This value will be somewhere here 10 at 60. So 50 minus 10. Slope will be equal to 5 by. So this will be equal to 50 minus 10, right? So 15 minus 10 is 5 by 30. That is also equal to 1 by 6. So this is also 1 by 6. But what they have asked you, sir, average delay. Average delay. Average delay means here the area of this region. The average delay means area of this region. How to find out area of this region? Total area minus half into 96 into 16 minus area of this triangle. This is 30 and this is 15. So half into 30 into 50 minus area of this trapezoid. Area of this trapezoid. This is 6 and we have this is 6 and this is 15 and 16. Okay, minus half into h into a plus b. So 6 into 15 plus 16 divided by area of this triangle divided by n, not n dash, it is should be n. So divided by 15, you will get a value of average delay per vehicle is 28.125 seconds. How much you will get, sir? 28.125 seconds. This is the average delay per vehicle. How do you calculate, sir? The area of this shaded region, you will be calculating total area minus this area, you will get this. Okay. Clear, students? Okay, please solve this. Next, similar kind of question, you will get a better understanding. I hope you can solve this problem. Just go through this question. Enough time. Sir, in the previous problem, if you see here if you see the saturation flow, here we have taken 15 minus 0 we have to take, sir. Okay, 15 minus 0 you have to take because this point is 0. Here we have 15 minus 0 by 90 minus 16. So this value will be equal to 1 by 2. So 1 by 2 into 3600 will give you 1800 vehicle per hour. Okay, so what is 1800 vehicle per hour is? 1800 vehicle per hour is nothing but the saturation flow and delay is 28.125 seconds. So if you see the options here, students, option B is correct because saturation flow is 1800 vehicle per hour and the average delay time is 28.125 seconds. I hope this solution is clear for you. Now see students, what they have given in this question is, they have given the cycle time, effective read time and effective. What is the average delay? See students, I told you average delay time, if you consider the average delay time, if you consider the average delay time, okay, average delay time is given by the formula C naught by 2 into 1 minus Gi by C naught whole square upon 1 minus lambda upon mu. Okay, 1 minus lambda upon mu. What is Gi by C naught? What is Gi by C naught, sir? What is Gi by C naught is? This is nothing but green ratio. What is Gi by C naught? It is nothing but green ratio. What is lambda, sir? It is nothing but arrival rate. What is mu? Mu is nothing but the departure rate. Okay, Gi by C naught is nothing but green ratio. C naught is nothing but the, what is C naught? C naught is nothing but the optimum cycle time. But in the problem, they've asked you, what is the, in the problem they have asked you, they've asked you what is the average delay. So this area you have to find out. What, sir? This, whatever the area you have here, this area you have to find out. Okay? How to find out this area, whichever they comes in this position. Okay? Now see students, here you can say total triangle is how much, sir? Here we have, this is how much we have? This is 40 and this distance is 50. So I'll find out the total triangle area. Suppose see students, I'll find out this triangle area, and from that triangle area, what I will do is I'll remove this part. So that is what I am trying to say. So here total triangle area is half into 50 into 40 minus, what is the area of this triangle? 30, 50. See students, this is important. The distance between 30 and 50 is 20. So here minus half into 20 into 40 divided by number of vehicles. So here what is the number of vehicles we have? Here it is 40. So divided by 40. So you see students, here this will be equal to 1000 minus 400 divided by 40. This will be equal to 600 divided by 40. This will be equal to 15 seconds. This will be equal to what, sir? 15 seconds. So here what I would like to tell you here is, if they ask you the triangle, sir, okay, if they ask you the triangle, means, sorry, not triangle, I should say average delay per vehicle. Okay, you have to see students, you can say here, if I have given the values like this, okay, if I take this as O, this is P and this is Q, you can say average delay per vehicle can be written as triangle OPQ divided by what is the number of vehicles here divided by N. This will give you the average delay per vehicle based on the formulas. Students, is this clear, sir? Now please go through this problem, students. Now see students, here we have a question. Now the question here is, for the hottest month of the year, the proposed airport side, the monthly mean temperature is 39 degrees. Okay, the average temperature is how much students? It is 39 degrees. And the maximum temperature is how much? The maximum daily temperature is 48 degrees. So he is asking what is ART? We call it as airport reference temperature. See students, when they ask you what is the airport reference temperature, if they ask you what is the airport reference temperature, airport reference ART can be written as, airport reference temperature ART can be written as TA plus average temperature plus maximum temperature minus average temperature upon 3. This is the basic formula we have for airport reference temperature. Here if you talk about the airport reference temperature, that is 39 degrees, maximum temperature is 48 minus 39 divided by 3. So this value will be equal to 42 degrees centigrade. Okay, so the answer here is 42 degrees centigrade. Option A is correct, students. Now this is an important question, students. Please go through this question. See students, here you should be clear with this problem. Here what is happening is correction for elevation. If you talk about the correction for elevation, for every 300 meter height, the correction for elevation is 7 percentile. Now for an elevation of, given in the problem, 535 meter, what will be the value? So it is nothing but 535 divided by 300 into 7 will give you the correction for the elevation of 535 meter. So, sorry, 300. So this will be, value will be equal to how much, sir? You will get a value of 12.483. Okay. Now see students, if you get 12.483 here, now they have given the basic runway length as how much, sir? If you see, they have given as 2000 meter. Sorry. Yeah, the basic standard conditions, the length of runway is how much, sir? 2000 meter. Now, after applying the correction for elevation, how much it is? 12.483. So, 12.483 into 2000 percentile. This is percentile, sir. 12.483 percentile. So, into 2000, as it is in percentile, we have to make divided by 100. So 20 into 12.48, it will be 249.67. So you will get a value of 2249.67 meter. Similarly, see students, he has asked to do the problem up to the correction for temperature. If you see the correction for temperature is given by the formula 15 minus 0.0065 into height. Here this is the temperature, okay? Correction. So here what you have to do is 15 degrees, okay? 15 minus 0.0065 into 535. Okay, if you do this value, how much you will be getting, sir? Can anyone tell me what is the value you got? What is the value you got, sir? You will get a value of how much? 11.525. Okay, but they have given the standard temperature is how much, sir? They have given the standard temperature as 22.625. So they have given the standard temperature as 22.625 minus 11.525. If you do roughly, you will get the value of how much, sir? 11.1, right? Have you got this value? It will be 11.1 percentile. Now see students, very good, Avian Singh. Very good. So here, if you got 11.1 percentile, what is the length here you got, sir? 22469 point, okay, you will get 224.49.69 meter. Now the corrected length, if I talk about the corrected length, you will have 22469.67 divide plus, what is the correction for temperature, sir? It is 11.1 by 100 into 2249.67. Okay, if you solve this, you will get a value of 2500 meter. You will get a value of 2500 meter. If you see this value, you will get around 250.33 meter, roughly, sir. Okay, so the answer here is 2500. So let me tell you one important thing here, students. If you doing the correction for elevation, for every height of 300 meter elevation, the correction is standardized as 7 percentile. Okay. After that, let me tell you, after doing this correction, we have the temperature correction. Temperature correction is how much, sir? 15 minus 0.0065 upon h, where h is the height of the elevation. After getting, suppose here you got 11, sir, something like, how much you got, sir? If I am not wrong, you got some 11.525. Okay, this is the value. But the standardized value is 22.625 minus 11.525. Here, let me tell you another important concept, Amma. For every, this is, what is the difference in temperature, sir? We got 11.1 degrees temperature. Now, let me tell you, for every 1 degree rise, sir, this is also important. You can ask me, actually I forgot to tell you there. For every 1 degree rise, the correction or rise or fall, for every 1 degree temperature, you will have a correction of 1 percentile. So you got 11.1, so I have taken 11.1 percentile. So it will be equal to 250.33. On adding this, we got 2500. Avigyan Singh, is it clear, sir? So there are two things. One is the temperature correction and other one is what, sir? The other one is nothing but the elevation correction. Now just go through this problem, students. Is it clear, Avigyan Singh? Okay, let me tell you this question. Now see students, the question here is, in an aggregate mix, the portions of coarse aggregate, fine aggregate and mineral filler are 55, 40 and 5% respectively. The values of the specific gravity of coarse aggregate, fine aggregate are 2.55, 2.66 and 2.70 respectively. The bulk specific gravity of the thing. So here see students, we have one is what sir? Coarse aggregate, fine aggregate and other one we have is filler. So there are three materials, right? So the bulk specific gravity GT is given by the formula 100 upon W1 percentile upon G1 plus W2 percentile upon G2 plus W3 percentile upon G3. Okay, here if you see the percentile, how much sir? 50, 40 and 5. 50. So it will be equal to 100 upon 50, 40, 55, 40 and 5. So 55 plus 40 plus 5. But G1 also we have to see. What is G1 sir? 2.55. 2.55 upon 2.65 upon 2.70. See students, actually I would like to tell you here. Here what is W1? Weight of coarse aggregate, weight of filler or weight of filler here. Sorry, coarse, fine and filler. If there is bitumen also, actual formula is what is sir? Specific gravity or theoretical specific gravity is nothing but 100 upon W1 percentile by G1 plus W2 percentile by G2, W2 percentile by G2 plus W3 percentile by G3 plus WB percentile by upon GB. Okay. Here see students, what I would like to tell you here is W1 is nothing but weight of coarse aggregate, W2 is weight of fine aggregate, W3 is filler and WB is weight of bitumen. Okay, now if you here bitumen is not given, so I have not considered that value and I have done. On solving this, you will get a value of 2.6. So the bulk specific gravity here is how much students? It will be equal to 2.6. Now please solve this problem. Now see students here, in a Marshall sample, the bulk specific gravity mix of aggregates are 2.324 and aggregates is 2.5246 respectively. The sample includes 5% of bitumen and specific gravity of bitumen is G 1.1. The theoretical maximum specific gravity is 2.44. The voids filled in the bitumen is. Now see students, first of all let me tell you volume of voids is given by the formula GT minus GM theoretical specific gravity upon GT minus GM by GT into 100. Okay, here what is volume of voids sir? GT minus GM by GT into 100. And we also have volume of voids filled in the bitumen. VB percentile is equal to WB percentile into GM by GB. Okay. Now voids filled in bitumen or VFB is equal to voids of bitumen upon VV plus VB into 100 or you can write volume of voids plus volume of bitumen is nothing but volume of mineral aggregates. Okay. Here see students, theoretical specific gravity. What is the theoretical specific gravity they have given? 2.441. See, theoretical specific gravity is given as 2.441 and the mass specific gravity is given as how much, sir? 2.324 of the mix. So 2.324 divided by GT is how much, sir? 2.441 into 100. This will be equal to VV percentile. So my dear students, what is the value of VV, sir? 4.79 percentile. What is the value of VV? It will be equal to 4.79 percentile. This is VB. Now what is VB? VB is equal to weight of bitumen into mass specific gravity upon bulk specific gravity of bitumen. Weight of bitumen is how much, sir? What is the weight of bitumen? Weight of bitumen sample 5 percentile and specific gravity is 1.1 and the aggregate is how much, sir? 2.324. Okay, 2.3. Here it is, weight is 5, 2.324 and the specific gravity of bitumen is how much? Specific gravity of, are you following students? First we have done volume of voids is GT minus GM by GT into 100, where GT indicates the theoretical specific gravity and GM is the mass specific gravity. On solving that, we got VB is equal to 4.79 percentile. VB is equal to W into GM by GB. So what will be this value, sir? If you solve this, you will get a value of 10.563 percentile. 10.563 percentile. Okay. Is this clear, sir? Now see students. Now see here. We have got this. Here you should understand, see students. VFB is equal to VB plus VV plus VB into 100. So what is VB, sir? We got 10.563 divided by VV is how much? 4.79 plus 10.563 into 100. Okay, if you solve this, what will be the percentage you will get, students? The percentage value will be equal to 68.78 percentile. This value will be equal to how much, sir? 68.78 percentile. Clear, students? Next, let me do. Now see, students, there was another important question. For an axial load of 15 tons on a road, the vehicle damage factor in terms of standard axial load of 8 tons. See students, in some questions, vehicle damage standard axial load also they will not give you. They will not give you this 8 tons also. You have to remember. So vehicle damage factor is given by the formula L by L power R power 4. Okay, here the axial load is given as, what is L? L is the axial load and LR is the standard axial load. So here you can write it as 15 divided by 8 power 4. So what is the value you got, students? What is the value you got, sir? You will get a value of 12.35. Okay. Now see students. Students, I hope you have enjoyed the sessions on the transportation engineering. I have covered the geometric design, airport corrections and traffic engineering. In today's session, I have covered the traffic engineering with spot speeds, average delay in vehicles, space mean speed and time headway, or you can say green shield model, which is very important. I have done different types of models related to the maximum traffic flow and also when the flow will be maximum in case of traffic density, in case of velocity, in case of flow also. We have discussed some concept related to the shock wave. So my dear students, these kind of problems will definitely help you in solving the gate questions. We have done the optimum cycle length also, green ratio, all those things. So students, if you want to access today's classroom, you have to join in this Telegram group. In the Telegram group, remember my dear students, we are daily posting the quizzes which will be helpful in solving the which will help you to solve for the GATE exam. Means suppose if you are trying to practice some problems which are very typical or anything, you can join in on our Telegram group, and whatever the GATE questions which you have posted within 24 hours of time, we will be posting the solutions also. Apart from this, to see students, we at IMS GATE Academy have a very important features. We offer 800 plus hours of GATE coaching students. And remember students, with this 45 years of industry with IMS GATE Academy, the key success for the student success means the key mantra for student success we can say is the My Plan session and one-to-one mentorship session, and also we have doubt solving portal. So we understand the student problems, we identify their weakness, we will give a clear roadmap for the entire year where you have to read, how the flow of subject and all. In addition to this, we provide very good material for subject wise, chapter wise and exercise book where it contains level 1, level 2, level 3 questions. Apart from this, we are providing 30 years of GATE questions with previously solved GATE question booklet. We will be providing that to the students, and we are providing the most important thing, key pointer for every question. So remember students, if you want to practice and test yourself, then you have to look for seriously for a test series. Then we at IMS GATE Academy provide 130 plus test series which include chapter test, subject test, multiple test, advanced level test, and we have the All India mock test series which is like a replica of the GATE environment, how you write in the GATE exam. So these kind of test series will definitely help you. Students, these two classes on transportation which I have covered on geometric design and traffic engineering and also the corrections definitely will help you, and please watch these videos and share to your friends who are interested and preparing for the most conceptual problems. Thank you and all the best for GATE 24. All the best. Thank you students.